Hey yo, what's up guys? Baby Bear 4812 coming at you one more time. Today with problem number 1249, or minimum remove to make valid parentheses. This question is being asked by Facebook a lot. Okay, so they really like this one. I think it's a good problem. I don't think it's overly difficult. It kind of reminded me of valid parentheses or valid brackets problem, which I think is an easy problem. And quite frankly, when I first did this one, I almost tried to correlate, I think, a bit too much of that problem into here, and it kind of tripped me up. And I thought that there was a pretty easy and clever solution to how to do this one, and so I figured maybe it would make for a good video, and I hope it does. We're given a string s of open parentheses, close parentheses, and lowercase English letters. The task is to remove the minimum number of parentheses in any positions so that the resulting parentheses string is valid and return any valid string. Okay, so we're given a string that contains letters and parentheses, and the parentheses need to be balanced. If they're balanced, we return the string. If they're not balanced, we need to remove the minimum possible number of parentheses and then return the resulting string. We're told formally a parentheses string is valid if and only if it is the empty string, if it contains only lowercase letters, or it can be written as AB, where A is concatenated with B, where A and B are valid strings, or it can be written as such where A is a valid string. I don't think that helps much. Again, there needs to be, when parentheses are well balanced, it means there's the same number of open and closed ones. And the other thing you need to take into account is that there are never more closed parentheses than open ones. So one key thing to know when we're thinking about this problem is that if I have more closed parentheses than I have open ones, then there's no way to rectify that situation. I can't then at some point put an opening parenthesis or an opening bracket and say, okay, well, they're balanced out now. If we have too many closing ones on one hand, it's done. So that's not balanced. What makes it slightly trickier though is if we have too many open ones. So we can imagine we started off looking at a string like this, and we had open, open, and then we closed two of them, so we're okay. And then at some point, what if we open more parentheses as we went? And you never know if you have too many open parentheses until you get to the end of the string. What that means is we'll have to necessitate some sort of at least one walkthrough to determine how many of both we have, and see if there's a clever way to find that balance and what the total kind of net result would be. To look at one example concretely, we can see here that it looks balanced up to here, and then this final parenthesis at the end is one too many closing parentheses, so we would drop that one. Okay, we're also told that there's another acceptable solution, which would be if we dropped this extra closing parenthesis instead. By extension, this one is also, any one of these three would have been valid. They're not looking for any answer in particular. In this one over here, we've got this extra, this solo closing parenthesis over here, which we need to drop. In this case, we've got all parentheses, and as you can see, we'd have to drop all of them and then return an empty string, which is valid. So I think you guys get the point here. Again, we're told that the characters are either open or closed parentheses or lowercase English letter, and we're given some length up to give or take 10,000. So that usually means if we get up to 10,000, n squared isn't really going to cut it. We're going to do this in O of n time and space. Don't worry about that. But generally, that's really all this constraint tells us. Now, how do we actually think about doing this? Well, one thing we need to note is that when we're working with strings, in most languages, definitely in Python and in Java, strings are immutable, meaning we cannot change the string directly. Okay, that means then we have to do a couple things. Either one is we can say maybe we can do a walkthrough and we can build our own string from scratch, like a result string, and append items on there as needed. The other way to go about it is to say, and the one that we're going to do, is to notice that if I want to change a string, I could take a string and split it into an array where every character will be its own array item. And from there, I can change those individual items, correspondingly. And net, when we're done with those individual transformations, we can lump it all back in together and return a string. So like the split and join functions. we're going to find a way to leverage that here. In this case, that requires that we do have O of n space, so we won't be doing that in constant space, but it does give us a pretty neat solution nonetheless. What we want to do then is to think about the following. I'm going to, so what I've done is I've written out the Leetcode example that we were given. So this was example number 1 here. And I've written an index out for each of these characters so we can follow along. So imagine that I did, if this is S, imagine I did something like S as a list. Okay, and what that'll do is it'll just be a split version of this string. And what we do is we would have an array. Okay, my computer's starting to lag. We would have an array. And I have these all in capital case just because it was easier to read, and I don't have the strings around, but I think you guys will get the idea anyways. There are a few things that can happen. As I'm iterating through the string, I can, on the one hand, I can come across a letter. On the other, I can come across an open parenthesis, and on the third, I can come across a closing parenthesis. So imagine that I had this thing split out. So I had, I'm really gonna, maybe I'll rewrite this all quickly. I will do it in a lowercase this time. If I'm walking through item by item, okay, my characters will be fine. I never really need to change those. I come across an opening parenthesis now. Okay, so now I think to myself, what can I possibly do with this? So if it's a closing parenthesis, we know right off the bat, like it needs to be matched with an open one. And so, you know, with the, I don't know why my pen just switched off. With the open ones though, we don't know whether or not we're going to end up closing them properly. So what we could actually end up doing, and this is kind of the where we get a bit of a quantum leap in imagination, is to say, well, what if I looked at, since we're splitting up the string anyways, what if I looked at the indices where the open parentheses are? If I have an open parenthesis, or if I have multiple, when I come across a closing parenthesis, I'll realize that, okay, these match. I have a matching opening and closed pair, and so I don't need to worry about this one not being closed. Okay? If I was to keep up, so say I call this stack here. And this is going to be the key idea of what we want to do. This stack is going to keep track of our parentheses. So maybe I'll just call them parens for short, or our parentheses. I'm walking through this string or through this array after I split it, and I come across an opening parenthesis. Okay? So I can tell myself it occurs at index 3. So let me make a note that I have an open parenthesis at index 3, okay? I keep walking along, and this will make sense as I finish up this walkthrough. I see my next one at index 5. Okay, I can pop on that index here. The reason I'm doing that is as follows. I now get to index 7, and I realize, okay, I have a closed parenthesis. Because I have a closed parenthesis, either one or two things can happen. If I've got a closed parenthesis, and there's at least one corresponding open parenthesis, I'm good. I'm not worried about this thing. This thing is not bothering me, okay? Because it's actually balanced out. So what we're going to do is we're going to say, let's leave that thing as it is. So what I haven't been doing as I've been walking through is kind of copying down the rest of these and what we're going to do with them. So I've got the T here. I had another open parenthesis. I had a C. And then I came across my closed parenthesis. Since I'm all right with this closed parenthesis, and again, the reason is because I have at least one corresponding open parenthesis, I'm going to leave that one as it is. I'm not going to touch it. Since I'm including that one, and we've now matched an opening with the closing parenthesis, I'm going to pop this index off. This means that I'm no longer concerned with the potential that this open parenthesis at index 5 is in excess. We've matched it up with something, namely with the closing parenthesis at index 7. I continue on my walkthrough through my string. I get to index 8 here, and I see an O. O is fine. We're going to leave the O as it is. I'm at index 9 now, and I come across another closing parenthesis. I ask myself now, is there already an open parenthesis that this corresponds to, that this balances out with? Yes, there is, because our stack has at least one item on it, and that item is 3. Since that's the case, I'll say, okay, I'm happy with that one. I don't need to get rid of it. I've now balanced out this opening parenthesis at index 3. I will pop it off and say this can now be balanced with no other closing parentheses. We've already used it. It's already paired. I keep walking through. I get to index 10. I see a letter. Again, letters are all good. I'll never have to modify those. E at index 11. Index 12 now, we have a closed parenthesis. I ask myself, is this closed parenthesis matched with the potential opening parenthesis? The answer is no, it's not. It's not because our stack of open parentheses, or their indices, is empty. There are no longer any preceding open parentheses that we can use to match this thing. Now, since this is a string and we can't modify it directly, but I still want to drop it, in this array that I've split, what I'm going to do is, originally it was just a closed parenthesis. I can change that to just be an empty string. What happens now is I've dropped this closing parenthesis. When at the end of my function I come back and say, let me, I've got this array now, let me join the letters back together, we are now going to be without this closing parenthesis. And that's really, that's the crux. I feel like I use that word in every video, but it's the idea that underlies how we're going to solve this problem. What I do want to show you though is let's imagine that instead of having this closed parenthesis, we have this open parenthesis now. Okay, so we're going to deal with the other issue. We're going to do it in a similar way. After I do this walkthrough that I just described, what we can do is jump in a quick loop, and sorry, now we have the index 12 here on our stack. What we can do is take a step and say, if there are items on the stack, in this case there's one item, let's deal with those items. If there are items on the stack, that means that there are more opening parentheses than there were closing ones. And that tells us that there's some open parentheses that shouldn't be open parentheses anymore. What we can do then is to say, let me loop through the stack, pop off the items one at a time. Each of those will give me an index. In this case, the index is 12. I will go to my array, this list I have over here, and say, take the index here, which I know was an open parenthesis right here, and change it to an empty string. Okay? That is our effective way of dropping that open parenthesis from the list, and now we can return it exactly the same way. So I hope this explanation made sense on how we're going to solve this thing. I think it's a bit of a clever solution. Again, maybe not necessarily obvious, at least it wasn't to me, but it gives us a nice and clean way to deal with the balance of the opening and the closing parentheses. So at this point, I think we're ready to jump into the code. Let me know in the comments down below if there's something I haven't explained or something that maybe I can clarify. Otherwise, let's have a look. The first thing we can do, and is kind of the usual error checking, and I think that it may be redundant here, so maybe I'll go back and clean it up after. But we'll start by doing our error checking. Then what we're going to have to do is we're going to want to split the string, as we said. So we're going to want to split string. We're going to want to create our stack, create stack. And after we create the stack, we are going to want to do we're going to loop through chars and modify parentheses as needed. Okay, so that was, and then when I say that, I'm referring to this step over here where we kind of did a walkthrough character by character and said, okay, if it's a letter, we're good. If it's an open bracket, let's add it to the stack. If it's a closed bracket, we'll compare it to what the stack looks like and that whole jazz, kind of one at a time. After we do that, we need to check if there are excess open parens and remove them. Then finally, we are going to want to return joined answer. So these are the I was going to say high-level steps. I don't think they're high-level. Maybe I went a bit too into the details here on how we're going to answer this. But the code will be relatively short, so I think that this will make sense. For the error checking portion, we'll just say if not s, we're going to return just an empty string. So if we're given an empty string, we'll return it because it's all good. Again, I think though that this may be redundant after. To split the string, we could do it in place. I'm going to go ahead and create a new variable just so it's a bit cleaner. Maybe I'll call it slist. And we'll do that by saying s.split, just like that. So we'll split every character individually. This create stack and create stack, and go put this here together, is I'll call this maybe open parentheses, or maybe open paren stack. And that'll just be a standard stack. And now we're going to loop through all the characters and modify them as we need to. So what I'll do is I'm actually going to enumerate through this because at every given point, I'm going to be interested in the character and I'm going to be interested in the index that it's in. The reason I'm interested in the index is because we might want to pop it onto the stack if it's an open parenthesis. So I'll say for I for index and C for character, and enumerate S, and we'll say the following. We'll say if our character is an open parenthesis, then all we're going to do is we'll say open paren stack dot append its index. Okay. Otherwise, if it's equal to a closed parenthesis, then we'll have a bit more logic. Notice that I'm not going to do an else statement here on saying if it's equal to, if it's just an alphabetic character, so something like L if C dot is alpha, because we're not going to touch those characters. They'll remain as they are, so I'm not going to be doing any checks for them. What I'm going to say is this, I'm going to say that if there are open parentheses, okay, so if open paren stack, if it's got any length, it's got any items on it at all, then we're going to want to take the open paren stack and pop off the top item because we know it's now been closed. And what we'll do is in our split list, we'll say S list at the index I is equal to, oh, sorry, no, we're not going to do that. We're just going to pop it off the stack, and that basically tells us that it's been paired with the closing parenthesis. We are happy with that closing parenthesis. Okay, we don't have an issue with it. It's going to stay within the string itself because we have something to balance it out. Otherwise, though, if there isn't anything on the stack, so if we have an empty open parenthesis stack, then we're going to want to take our S list at index I and set it equal to an empty string. Okay. That's going to turn that closing parenthesis into an empty string so that we've de facto dropped it from our result at the end of the day. And let me think here. So that's pretty much it for this for loop. If we have an open parenthesis, we see we're going to add it to the stack. Otherwise, if it's a closed one, we're going to pop the open one from the stack if there's something on it. Otherwise, if there isn't, we're going to just kind of wipe that closed parenthesis out entirely. I'm going to move this over a bit more just so I'm not coding over my face isn't over the code. So here we need to check if there are any excess open parentheses and remove them systematically. So we'll say while open paren stack. So while there is something on that stack, we're going to take that number that when we pop these off of the stack, we actually get an index, right? So maybe I could say something like, and I can do this in one step, but I'll split it out a bit. So maybe I'll say open paren index is equal to open paren stack dot pop. This means that we had an excess open parenthesis at an index, open parenthesis index, open paren index. I now want to scrap that open paren index from our final answer. I don't want it there. It was excessive. So I'll say slist at open paren index is equal to just an empty string. I've wiped it out of my answer. Finally, we want to return the actual joined answer after we've gone through all these cleanups, and that'll just be return empty string dot join s list. And if I run that, that should be it. It's not, because I should have said equals equals. That is also not working because what did I do? Empty separator. Oh, I think for the empty separator, I don't put anything at all. Oh boy, what am I doing here? I've made a whole bunch of small mistakes. It says list assignment index out of range. Is that possible? Okay, what did I do here? You know what? I'm sorry. I think that I was mixing up my languages here. I think the easiest way to do this is just to say list of S. I think I was thinking in JavaScript, and that's probably what got me. So let me just try to run this and make sure that there are no other mistakes. All right, so we got it. I'm sorry about that. Again, if that syntax caused any confusion, there may be a different way to do that. I'll check my syntax after. I got to go back to the documentation. But irrespective of all that, quick summary of what we did. This error checking it again, I don't think we need it necessarily. But anyways, we did our error checking. We took our list and we split it into individual characters. A good reason to do this is because strings are immutable in Python and again in many other languages. So if we want to modify individual inputs, we can always split it so we get a list or an array of the individual characters, and then we can join it back together in our final answer. We then enumerated through, and we said that if we find open parentheses, we'll add them to the stack where we're going to keep the track of all the indices of the open ones. And when we find a closing parenthesis, If there are items we can match them with, namely open parentheses, we will match them. So we'll pop that item off the stack and we're happy. We're not changing anything. Although if we find an excess closing parenthesis, we'll change it immediately. Okay, we'll remove it on site. When we get to the end of this list, it may mean that we have too many open parentheses. And what we'll do is we'll pop those off one by one off of our stack and change them to individually be empty strings. So finally, when we join everything back together, we get the desired answer. I hope that explanation made sense. I hope it helped. Hope you enjoyed the video. Let me know if you have any questions down below. Let me know how else I can help you guys. If maybe there's a different style of video or different questions that that I could do to help push you along if you're aching anywhere. So do let me know. I do appreciate it. Share this with everyone, as always. Please. Wow, that sounded desperate. Or not. If you do share it, awesome. If you don't, a bit less awesome, but you're still awesome nonetheless. All right? I'll see you guys next time. Peace.